Okay, so this is about bubblesort. Bubblesort is an algorithm that can be used on unsorted lists. So if you have an array like this, there's 5, 1, 4, 2, 8. So these numbers are unsorted, right? What we do is we loop through we loop through the array, however many times there are elements in the array. And the thing about bubblesort is, well, say if you're sorting in ascending order, which is what this is doing, the biggest one will bubble to the top, right? If we want to do it in descending order, the smallest one will also bubble to the end, right? That's why it's called bubblesort. It works by comparing each indice to the next one. So, for example, we look at 5 and 1 and we say, is 5 bigger than 1? So is the thing at index 0 bigger than the thing at index 1? Or if we're using a counter I in a loop, because this is a for loop looping through, we say, is index I bigger than index I plus 1? Is the thing at index I plus 1? It is, therefore we swap it, so we get to here. Then we compare these two. Is that bigger? It is, so we swap it. Then we get to here. Is that bigger than that one? It is, so we swap it. Then we get to here. Then we get to here. There are no swaps because 5 is not bigger than 8. And then that's our first pass. And then we move into the second pass. So how do we know whether we need to go to a second pass or not? Well, we've got a variable called swapped, and that's a Boolean variable. And this is getting into the coding of it. And if the variable is true, then we know a swap has occurred. So this would be true because during that iteration of like 0 to the end of that list, there was a swap. So true, so swapped is true. If at any point swapped is not true, we know that we don't have to go through another loop like this. Also, there's another thing we need to hold in our memories, and that is that to know how to program this, and that is that once we've done one loop, we know that we don't need to go from 0 to 1, 2, 3, 4 again, because we know that we'll have this bit will be sorted. The last one is in the right place, so we don't need to check it again. We know there's nothing else that's bigger than that. So here we're just going to go 0 to 1, 2, 3. And that makes it slightly efficient, means we don't have to do as many iterations through this for loop. Okay, so that's how bubblesort works. Compares it, swaps them over. The thing about bubblesort is it's not very efficient, as you'll find out. Why? Because we're doing a loop within a loop. So we're looping over the like the worst possible case of bubblesort is n squared. Sorry, yeah, n squared. And the average case is n squared. The best case is n squared. That's because it's a loop within a loop. So we're looping over it. The number of elements there are in the list times the number of elements there are in the list, because it's a loop within a loop. So if there's 5 elements in the list, the worst, best, and average case is 5 times 5, or 5 squared, and that is 25. So this algorithm, if we look at this chart here, is what's called polynomial, is n squared. So it's very, very bad. It's all right for very short lists, for programming something very simple, but for anything bigger than, say, a few items, it's going to be really, really bad. So we wouldn't want to use bubblesort really for anything, unless we've got a very, very small list and we just want to program something quickly. I suppose also one positive point about it is that perhaps it uses up less memory. It's not a recursive algorithm, as we'll come on to later. The recursion needs to store every state of the memory in the stack frame. It's just looping, and it's very simple to set up. Okay, so how are we going to program this? The way I would do this is, let's talk through like the pseudocode. What are the inputs? What are the decisions? And what are the processes? And then go away and think about it and try and program it yourself, or pause the video when I say have a go yourself, and then if you still can't do it, watch the video and I'll explain it to you. So here I've broken this down. This link will be linked in the video below. So we've got the list. So we pass this list to a function that's going to sort it. It's unordered, right? That's the key thing about bubblesort. There's no point trying to order an ordered list, but it's unordered. So we've got this Boolean variable swapped. We've also got a variable called n, which is the length of the list. Now, on every loop of the outer loop, the while loop, we're going to reduce n by 1 because we know the last element is going to be sorted. Then we've got the while loop. So it swaps. While swaps is true, while a swap has occurred. So really that should say we should initialize swaps to true. While swaps is equal to true, so at least we do it at least once. Keep doing this inner for loop, right? And then we're going to set swaps to false. We'll come on to that. The length of the list, we need to take 1 off it every time. So on every loop of this while loop, we're going to minus 1 off it because we know what length the thing is sorted by the end. Then we've got this inner for loop, right? So we're setting up a for loop here. We're starting at the beginning of the list and we're going from 0 to the end, or yeah. And then we're looking at every element and we're looking at the current element and the one in front of it, and we're saying, because we're going to sort this in ascending order, we're saying, is this one bigger than this one? If it is, we do need to swap them. If that is true, then we need to do this little swap thing here. How can you swap elements in an array over? Well, you need a temp variable. That temp variable is going to hold, if I bring this up, it's probably easier to look at it. How do we swap these elements over? Well, if I want to put this one into this position, so I'm going to move the thing at I plus 1 and put it into 0. I don't want to override that, right? So I want to store that in a temp variable up here. And then I'm going to say array at index I is equal to this, so that goes into there. And then I'm going to say array at index I plus 1 is equal to this temp, so it goes in there. So we need a temp variable to hold it, and that's if a swap needs to occur. So that's what is happening here, and then we're replacing temp with the thing at I plus 1. Then we need to say swaps is true, because a swap has occurred, right? And then we're going to go to the next I and keep going through trying to make these decisions. Is the one here greater than the one at I plus 1, and then swap them. Okay. So the reason we set swaps to false in the while loop is because we need to reset that. So, for example, if this doesn't happen, if there are no swaps after we've gone through the whole loop, swaps is false. Therefore, the next time we come round to the while condition, the loop will quit. Right. So go away and, looking at that, try and program this, or at the very least write some simple pseudocode on the paper here. Wonder if you can think that out. So think about it. You've got an outer while loop that will keep going over, keep looping while swaps is true, right? And then we've got this inner while loop that's going over. So imagine, like, whether or not we do a pass like this, like this, like this, depends on whether swaps is true. So we keep, and if it is true, we keep looping over the elements in the list, and we swap them if the one here is bigger than the one here. So pause the video, have a go at that. Okay, so you've come back for the answer. Hopefully you will get something a little bit like this. Now I'm going to create a function because we like functions, they're helpful, they break code up. This function is going to return my array of integers, sorted array, and it's going to be called bubblesort because it's going to do that. We're going to pass in the array to sort. Let's call it unordered. No, let's just call it array to sort. Okay. So I'm going to keep flipping back to my steps. When you know an algorithm, like when you can figure it out, like with the pieces of paper. So one thing you could do is you could take some pieces of paper and make 5 pieces of paper, put some other ordered things, see if you can loop through it. When it is, if you can, once you know what the algorithm is, you should try and write some steps out like this, see if you can do it. And then from that, try and program it. Right, so we've got a couple of variables here. We've got this bool, swapped. Swapped is going to be false. No, it's going to be true. So we do at least one loop of the while loop. And then we've got this length. So we've got int length equals array to sort dot length. Yeah. And then we've got the while loop. So this is our outer loop. This is what's going to loop through each condition, each iteration of. So it's what's going to loop through each one of these, each pass. Sorry. So while swapped is equal to true, right? We keep looping through it. We're going to say n equals n minus 1, right? So the length. The space that we need to keep doing the for loop through is going to reduce by 1 every time. And obviously on the first pass, we can never go to the length of the array. We always have to, because it'll be array out of bounds. So we're going to go to the length minus 1, right? So we've set that up. We also need to set swapped to be false. And the job of the for loop will therefore be to see if anything needs to be swapped, and if it does, set swap to true. If that never gets set back to true, then this loop will quit. Then we write our for loop. So we're going to set up our counter in I equals 0. So whilst I is less than n, right, or length, sorry, and then we're going to add 1 on each loop to go through. So now we're in our nested inner for loop, right? So this is where we've got to check, does the index I, is it greater than the index I plus 1? So we say if, and then array to sort, if that is greater than array to sort I plus 1, if that's true, then we're going to do the swap. What would you need to change here if we didn't want to sort this in ascending order? So if we wanted the numbers to be in descending order, what would you need to change here? Have a think about that. Put your answer in the comments below. In fact, if I ask you any questions about anything, put your answer in the comments below and like the video. So if, so we've done the if, right? If that is true, we're going to do, we need to swap. And what are we going to swap? Right, so we're going to have this temp. That's going to hold the thing at I in, so we're not going to override it. Array to sort I, right? If that is, so put that in the temp, and then we're going to say array to sort at I. We're going to replace the thing in front of it in that position. So we're going to put the 1 into position into index 0, right? We're going to put it in there, but it's going to wipe out whatever is in index 0, which is why we saved it in temp. So array to sort equals I plus 1. So we're going to override that thing in there. Then we're going to use this temp to restore the variable that we just wiped out. So, and the thing at index plus 1 is now going to be replaced with temp. So that does the swap, those 3 lines there. Okay. Then we need to say swapped equals true, because a swap will have occurred. So that's it basically. Whatever array we pass into this function, let's just test this out. Now there's in C#, I always forget this, C#, we want to print array as a string. We want to just see what result we get back. If we want to print that, then right, you can do a string.join thing like that. Yeah, I think so. Like this, you can just print out an array. So I'm going to call bubblesort, and hell, let's just call it with that array. So 51428 int, we're just going to pass an array directly into it. 51428. Okay. Now, why does it not like that? I think that should be all right. I just want to define an array like that, so that should be okay. The value that's returned is going to be an array, sorted array, and then we're going to print this sorted array, but we're going to not do new line character, we're just going to put a comma between. It's going to sort of enumerate through that array and print that off. So what's wrong with this? Probably just doesn't like the way I've defined it. Let's define it up here. Let's call it unsorted array. And then we're going to pass unsorted array into our function bubblesort. Oh yeah, one more thing. What do we need to do? We need to, I think this should work. We need to pass back the array that we've just sorted. So let's run that piece of code now. So it's going to create the unsorted array. Then it's going to pass that into bubblesort. Bubblesort will do its thing, keep looping around until no swaps have occurred. So a swap is false, the while loop will quit, and then it should pass that array to sort. And then it's going to use this string.join to print out the contents of an array, but join them by a comma. And there we go. We have sorted the array. So that is in ascending order. So see if you can change something very small in this code to make it do it in descending order. And also, have a go, and I'll put this in the link below, have a go at this kata. So this kata requires you to take an array of probably unsorted, perhaps, sort them in descending order like this, and then calculate the difference between each consecutive element. So once it's sorted in descending order, you need to do 10 minus 2 is 8, 2 minus 1 is 1, so 8 plus 1 is 9. And so you've got to create a function that's going to firstly sort it, and then you've got to do that calculation. So you can use bubblesort for this, and that would be a good practice for it. However, there are much easier, faster ways in C# to enumerate things. But for the purpose of OCR's exam and your understanding of arrays and loops, you need to use this. Okay, good luck, and let me know how you get on in the comments below.